How much potential does wave energy truly offer? Some experts believe it could deliver up to 10% of the world's electricity needs by 2050. Meet Bombora mWave, a system designed to generate electricity from waves. Their system consists of a series of air-inflated rubber membranes fixed to a steel structure that sits on the sea floor. As waves pass overhead, they compress the air inside these membranes, which flows through valves and drives a turbine to produce clean electricity. Thanks to its modular design, it is easy to repair and maintain. And its ability to automatically shut down during extreme storm conditions adds another advantage. Weighing about 900 tons, the 1.5 megawatt station spans 75 by 15 meters, making it ideal for deployment in both nearshore and offshore environments. The innovative solution displayed on the screen is designed to power offshore industries. Developed by the American company Ocean Power Technologies, this system, which they call PB3, is an uninterruptible power supply that harnesses wave energy to generate electricity. Capable of operating at depths between 20 and 3,000 meters, it uses a direct drive generator to convert the linear motion of its floating section, rising and falling with the waves, into electrical energy. This energy is stored in an onboard battery, ensuring continuous power supply even during calm sea conditions. During trials, it has generated over 2.7 megawatt hours of electricity. This technology is particularly beneficial for powering offshore equipment like underwater vehicles and marine surveillance systems. Additionally, it can support real-time data transfer and communication with remote onshore facilities. Following the successful deployment of its predecessors in Scotland and Nova Scotia, PLAT-I 6.40 is the second-generation tidal energy platform developed by UK engineers. This modular platform, equipped with 6 turbines, has a power generation capacity of 420 kilowatts and can operate in water as shallow as 2 meters. Notably, a standout feature of the platform are the self-raising turbines, which facilitate easy access for maintenance. Supported by $28.5 million from the Canadian government, the company plans to deliver the world's first floating tidal array near Nova Scotia. Once operational, they can generate up to 9 megawatts of power, enough to supply electricity to around 3,000 homes, while also reducing the region's carbon footprint by around 17,000 tons annually. This massive 16-meter structure, roughly the height of a 5-story building, was put into operation in Nova Scotia in 2016. At that time, it was the most powerful tidal turbine in North America with a capacity of 2 megawatts. One of the key advantages of these turbines is their mobility. They can be easily relocated or transported as needed. And this wasn't OpenHydro's first achievement. In 2006, the company tested its first 250 kilowatt turbine off the island of Ede, making it the first tidal turbine to connect to the UK national grid. However, despite these successes, the company faced financial difficulties and was liquidated in 2018. If you're having trouble putting trust in just wave energy, here's a Swedish company that combines all three: wave, wind, and solar power into a single system. This is how it works. The 38-meter-long platform has 6 vertical axis wind turbines that harness strong ocean winds to generate electricity. Solar panels installed along the platform's exterior capture sunlight to enhance energy output further. Interestingly, the platform itself also generates power using a large cylinder underneath. As waves lift the platform, this motion pumps water through a turbine, similar to an old garden pump, converting wave energy into electricity. Together, this hybrid system can produce up to 1 megawatt of electricity, enough to power about 324 average US homes. Currently, the company is testing smaller prototypes and aims to launch a full-scale pilot by 2030. Meanwhile, Sweden's EcoWave Power has been testing and developing its wave energy system for over a decade. According to its creators, it can capture energy from waves as small as half a meter high. The process of generating energy is simple. As waves rise and fall, these floaters move up and down, driving hydraulic pistons that power a generator, converting wave energy into clean electricity. This system can be installed along the coastline structures such as breakwaters and piers. When waves grow larger due to weather changes, the floaters automatically rise and stay in an upward position until the storm passes. Currently, the company is implementing its first megawatt-scale wave energy project with plans to expand up to 20 megawatts across 4 locations in Porto, Portugal. Don't forget to subscribe to Unstoppable Gadgets. And if you want to check out even more ways to generate energy, click on the screen for the next video.